Hello everyone, it's Miss Bolke here, and today I'm going to be teaching you guys how to solve a question that has to do with rates when people are working together. So you've probably seen questions like this, like person A can paint a room in this many hours, person B can do it in this many hours, so how many can they do it together? So this is this type of question, and I'm going to give you two different ways for you to solve, because obviously it's always better to find different ways to solve a question and have that understanding, and then you can choose which way you like best, and you may have another way to do it. But the more you know, the better it is, all right? So in this question, it's Molly, Holly, and Polly, okay, are working on a garden. So alone, Molly can finish the garden in 12 hours. So that's some information there. She can do it in 12 hours. Holly can complete the garden on her own in 10 hours, and Polly can do it in 8 hours. Okay, so individually, that's how many hours they each can complete this garden. Now, it's asking me how much time. So I want to know how much time it would take if they worked together. So right away, I'm like, oh, there's that work together. I know it's this type of question. So that's some hints on this is that we have a garden in 12 hours. So there's kind of a ratio, garden per hours and a rate per certain hours. We have gardens per certain hours. Then we are looking for our time and how much it takes them to work together. So here is the first way to solve this type of question. So I'm going to first start this, call this like the unit per garden per hour. Okay, so I have my units. I know that I have my gardens per hour. Molly, this is what the given information. Molly can do one garden per 12 hours. Holly can do one garden per 10 hours, and Polly can do one garden per 8 hours. So because I'm asking them, hey, how much time would it take for you to put them together? I can, together means adding all of them, doing this together, so I'm going to add it up. Okay, so I have my Molly 1 over 12 plus my Holly, which is 1 over 10, plus Polly. Okay, and then I'm going to find out what that equals. Now, if we did, luckily these 12, 10, and 8 are a nice little lowest common multiple, works out perfect for those. So why don't we just put that down? So if you did your adding fractions correctly, you should have came out to have 37 over 120. Okay, so this is going to be 37 gardens. Together, they can finish 37 gardens in 120 hours. However, that is not necessarily what the question is asking us. The question is asking us how much time it would take them to finish one garden if they work together. So now let's use proportional reasoning, okay? So if I know I have gardens per hour, so let's write down my information that I know. Gardens per hour, okay? We know we have 37 over 120, okay? So that's how many gardens per 120. So I want to know if they can do one garden to finish, how many hours would it take? So I'm going to let X represent the number of hours when they work together. Okay, so in this case, let's go, because I'm running out of room and I don't have another one of these boards. Let's go back to work with that, the information that we have. So we know now, let's use a different color here. We have 37 gardens that they can finish together in 120. And I'm trying to find, we have one garden to be completed in X amount of hours. So we can use our cross multiplication. You can watch the video if you don't remember how to do it, but or why it works. So we can now have 37x is equal to 120. So therefore, x is equal to 120 over 37. and that would mean X is equal to 3.25. So that's how many hours together it takes them to finish one garden. So therefore statement, it takes 3 hours, and so I think it's 25, so about 40 minutes. Okay. So that would be how you would solve it one way. Okay, so here is a different way of doing the same question, right, with the Molly, Holly, and Polly. So again, here's the information that we have, and we are trying to find out how much time it would take if they worked together. So in this case, now what I'm trying to do is find the hourly rate, okay? So I'm going about it a little differently. Now I'm going to have hours per garden. So in Molly's case, which would be, we know we have 12, it takes her 12 hours to do one garden. Okay, so instead of what I did last time, this time I want to find out how much garden can she do in 1 hour. So this, just to show you how that would work, is if I had 12 hours per one garden. Instead, I'm doing proportional reasoning. I want to know in 1 hour how much of the garden can she do. So my X will represent the garden. Okay, so I want to know how much of this garden can she do. So this, easy going through this, we know that in 1 hour, so I cross multiply, sorry, in 1 hour, Molly can do 1/12 of a garden. Okay, so now I have that information. So that means when I look back, if I know that Molly is going to be 1/12 of a garden in 1 hour, then that means that Holly is going to be 1/10 of a garden, and Polly's going to be 1/8 of a garden. Okay, so now that I have my hourly rate, okay, my unit rate for that, I'm able to go to my next step. So let's just work with Molly right now, because I know that Molly is in 1 hour, she can do 1/12 of the garden. So that means that in 2 hours, she could do double this. 3 hours, she can do triple. But we don't know how much time they're working together to complete this garden. So I'm going to call X the amount of time when Molly, Holly, and Polly work together. So to finish one garden. So that's what I'm trying to find here. I want to know how much time it takes them to work with, to figure out one garden. So if I know that X is that, and I was saying if I knew how much time they worked, then that means I can multiply this amount of time that they worked on this garden by each of their, how much of the garden they can do. So if they worked 2 hours, it would be, Molly would be able to complete her share of it, would be this doubled. So really, in essence, what I'm doing is X times, so how much time together, times Molly's amount of the garden. So we don't know how much it is, so if I multiply that, X times 1, X over 1 would be, X would be over 1 times 12, so that would be X over 12. So that means Molly would be X over 12. And then I could figure out the same for Holly. She would be X over 10, and then Polly would be X over 8. So now that I have all those three, I'm able to figure out, I can just add them together, okay? So now I have Molly's X over 12 plus Polly would be X over 10, Holly, plus Polly would be X over 8, okay? And I know that if I took the amount of time that I worked with her 1/12 and her 1/10 and her 1/8, so if I took each of theirs, they would then complete one garden, Okay. So then I'm able to use my adding fraction. So just to show you how that is, again, each of them are a nice lowest common denominator is 120. So in order for 12 to get 120, I would, sorry, yeah, what, was it 12? 10? Yeah. So in order for 12, we would have 10 x, so 12 divided by, sorry, 120 divided by 12 would be 10x. Then we'd have 12x, then we'd have 15x. So we could add each of these together and we'd have 37x over 120 would equal 1 garden. Then I just use my cross multiplication. It would turn out the exact same that we just did. So it would be 37x equals 120. So therefore x equals 120 divided by 37. And then we would have x would equal 3.24. Okay, and then we can convert that, and it works out to be around 3 hours and 40 minutes. Fabulous. So there are the two different ways. All right, so one of them again was going using my what did I use? My garden. I can't remember because I don't have them all written down. But either way, I showed you two different ways. Have a fabulous time with those. And hopefully that helped and you liked one of the ways. All right.